All right, another great question for you guys, similar to the last one. We have uh, grass clippings. So we've got kind of this pile of clippings, and we don't have anything that we're being added on, but we do have departing. So it's decaying. Okay, so we're not adding, but it's decaying in this time. Okay, and so it's decaying. It says that the amount is equal to that. Okay, this function right there over the course of 30 days. And problem A says find the average rate of change over the interval. Find the average rate of change. Well, instantaneous rate of change is the derivative. Average rate of change, average rate is slope. Okay, so in order to get the first points, you just have to do slope. So A of 30 minus A of 0 divided by 30 minus 0. Okay, that's all we need to do. Just use our little slope formula. So I go to my calculator, go into my y equals, get rid of my stuff from the previous problem we just did, and I'm going to enter 6.687 times 0.931 raised to the t power. Okay, and I'm going to go into my table, and I'm going to type in 30, and I get 0.7829 minus, I'm going to type in 0, and I get, as you can see, 6.687 divided by 30. I'm going to calculate that. 0.7829 minus 6.687 divided by 30, negative 0.196. Whoop. And this is a rate. So what are we measuring? The amount of grass clippings, okay, is pounds. So pounds per, and time in this situation is measured in days. So that means each day, on average, it's losing 0.196 pounds of grass clippings each day, okay? So that's average rate of change over a given interval. If it said it wants an instantaneous rate of change, we do the derivative. Part B says, find the value of a prime of 15. A prime of 15. Well, that's the derivative. In order to find that, we just go into y, or our y equals, we have our function entered. In order to find the derivative, we just press 6. And now we need to use 15. Now, as you can see here, I only go to 10. So that's a problem. So I've got to change my window so I go at least to 15. So I'm going to put my x max all the way up to 20, and try this again. So I can calculate number 6. And I'm going to try at time 15. So I type in 15. It gives me negative 0.163. Negative 0.163. Okay, what does that mean? It's asking for what it means. It means the amount of grass clippings. It's a rate, so we like to know, is it increasing or decreasing? It looks like since the data is decreasing, amount of grass clippings is decreasing at a rate of 0.163 pounds per day. Okay, good example right there. Problem C, find the time at which the amount of grass clippings in the bin is equal to the average amount of grass clippings over the interval 0 to 30. That's a little bit complicated. When is the amount, the actual amount, equal to the average amount? Well, how do we find the average value of the function? How do we find the average value of the function? Well, average value of the function, we do the integral 0 to 30 of a of t dt, and 1 over 30 because that's the length of our interval. So I can actually calculate this. that's not a problem. I just, go to my window. I make sure my X max is all the way out to at least 30. We'll go to 35. We will calculate number 7. And I'm going to go from 0 to 30. And I get 82.579. So I have A of t is equal to 1 over 30 times 82.579. Okay, so let's actually calculate that. We've got 82.579. We're going to divide that by 30. And I get 2.7526. So when is the amount equal to 2.7526? Anytime I'm asked to solve an equation like that on an AP exam, I always do it like this. The amount minus 2.7526 is equal to 0. So solving that is the same as solving that. That way I get to use the 0 option on my calculator. Minus 2.7526. And so if we go ahead and graph that, we're going to look for where it crosses the x-axis. Crosses right there. How do we find that spot? We find the 0. So I could calculate number 0, or number 2 for 0. Left bound, enter. Right bound, enter. I get a grand total of 12.415. Time equals 12.415 days. That's a cool problem right there. Comes up. I brought it up because I want you to see the average value function. Comes up a lot. And I want you to see that. Okay, we're at 7 minutes here. We're going to keep rolling. We have the last part, problem D. And it says that what happens after 30? What happens after the 30 days? So day 40, 50, so on and so forth. And it says the linear approximation is a better model for amount of grass. Use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. When is there going to be 0.5 pounds of grass clippings remaining in the bin? Okay, so the deal is that it says the linear model. So if you want a linear model, that means you're going to have a line, from the time. So, it's like, so the graph looks like this. It's saying once you get to this, just kind of make a line at that point. Well, in order to make a line, you need two things. You need a point on your line and you need your slope. Okay? Point on your line and your slope. Well, 30 is the x value. And then the y value, if we go to our table, we can find the y value by typing in, I'm sorry, I got to get rid of this minus 2 point deal over here. Okay. So it's a 0.7829. 0.7829. And then your slope is the derivative. So if I calculate number 6, number 6 will tell me at that time that if I type in 30, that the derivative is negative 0.0559. Okay? So if you write your equation for your line, y minus y1 is equal to m times x minus x1, what we get is y minus 0.7829 is equal to 0.0559 times x minus 30. Okay? And this linear model right here, it gives us a really good indication of what it looks like as it goes out. So the question is, when will there be 0.5 pounds of grass? So when will there be 0.5? So we're wondering how many days will there be 0.5 pounds? Okay. So 0.5 minus 0.7829 is equal to 0.0559 times your x minus 30. So I take that 0.5, I subtract 0.7829, I get that. I'm going to divide by 0.0559, and I get that, and I'm going to add 30 to that. And, oh, I'm sorry, folks. I forgot the negative sign right there. My answer wasn't coming out. You look at the negative. I forgot my negative sign. Sorry. Let's try that one more time. 0.5 minus 0.7829. That's where I was going on because like I've done all this right. Divided by negative 0.0559. We get that. We add 30 to it. And then we get 35.060. And that's it. It actually looks like the answer key gives me 35.054. I wonder if that's a rounding error that exists. It looks like all of my work is pretty much right. I didn't write this out quite as far as they did for decimal approximation. Hopefully they'll be understanding in that regard, but looks like they come up with this. Maybe I didn't. Usually they say if you go to, they carry it out to 6 places there. I guess carrying out to more places is better. Let's see if we do try it like that, if we get the right thing. 0.5 minus 0.7829, and it carries on with 28. We get that, and we divide by negative 0.0559, and then they also have 7 6 there, so they carry it out further, and they get that, and then they add 30 to it. So they're not very specific. I guess carrying out to more decimal places is better. Your final answer needs to be to 3 decimal places, but in your work along the way, carrying out to more decimal places is better, I guess. So I probably should clean that up. I might have gotten a point off on that problem. So anyway, this is a good problem. Lots of opportunities to get points on this one. Yeah, just a great problem that involves those grass clippings as they decay and they decompose. Okay, so there you have it. We'll try another one.